Hello. Today we're going to be talking about functions. Functions sound like something new, but they're really nothing new. It's just a new way of looking at equations. You still have input and output, which is the same as the equations we've been dealing with up until now, where x is the input and y is the output. It's just a slightly different way of looking at an equation, and we call that a rule. Okay, so let's use the example that's in our book. I'm on page 153 in your textbook, and you can follow along, or you can put this on page 19 in your notes. It says Carlos needs to buy some new pencils from the school supply store at his school. Carlos asks his classmates if they know how much pencils cost. Angela said she bought 2 pencils for 50 cents. Paige bought 3 pencils for 75 cents. And Spencer bought 4 pencils for $1. Carlos thinks about the rule for the price of the pencil as a machine. When he puts the number of pencils he wants to buy into the machine applies a rule and then tells him the total cost of that number of pencils. So we can look at it like this. I'm going to draw a table. And this table is going to have 3 columns. Okay, so the first column is going to be the number of pencils. The middle column is what we're going to call the rule, and the last column is going to be the cost. So the first example was Angela bought 2 pencils and it cost her 50 cents. Somebody else bought 3 pencils and it cost 75 cents. Somebody bought 4 pencils and it cost $1. Okay, and you can go on further and you could say, okay, well, what if I bought 12 pencils or some X number of pencils? How much would it then cost? So here we took 2 and we multiplied it by 0.25. Here we took 3 and we multiplied it by 0.25, or 4 times 0.25. And you can pretty much see that no matter what number of pencils we have, some number x, we're going to take that x and we're going to multiply it by 0.25. And we're going to get 0.25x. Now, just like in equations that we learned last unit, we have input and we have output. And our input we normally think of as x, and that's the same. And our output we normally think of as y. Another way to say the output is f of x. So function of x. Okay? So when you're thinking about a function, instead of thinking of it as y, even though you graph it on the y-axis, you need to start thinking of it as a function of x, okay? Because you will see f of x. Now this is it as a table, but there's other diagrams that you could see, and you might see something like this diagram, okay? And it'll have numbers here, and this will be the input. And this will be the output. And the input will be something like this, and then the output will be something like this. Okay. Now, this might not make sense that if I put 2 in, I get 7, and if I put 4 in, I get 5. That doesn't actually matter. The key to make it a function is that for every input, you have only one output. Think of it this way. When Carlos is trying to figure out what the cost of pencils is, he shouldn't think, well, if I try to buy 10 pencils, it could cost this or this other price. No, it's only going to be one price. If there's 2 different prices, that means there's no real rule that gives him the cost of the pencils. So for a function to be a function, there can only be one output for every input. So let's look at two different charts with inputs and outputs. One is going to be a function and the other one is not going to be a function. Okay, here I have two different data tables, and you can see I have inputs and outputs, inputs and outputs, okay? This one, if you can see, for every input, there is only one output that matches, okay? However, in this one, for every input, there is one case where there's going to be two outputs, okay? And it's kind of confusing because you're thinking, oh, well, the output here and here, both of those are 15. That's actually okay because this 25 gives you an output of 15 and 15 gives you an output of 15. That's okay. Both of these inputs can have the same output. What can't happen is when I put 5 in, I get 1 or 3, so it looks like this. If I put 5 in to the rule, I don't know if I'm going to get 1 or 3. Okay, so therefore this is not a function. Whereas this is a function. Okay? Another way to think of this is on a graph. Okay? So we're just going to deal with quadrant 1 for right now. Okay? A function is only going to have one output for every input. So if you were to graph something, you could have a point here and here, 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 and here, and here. Okay? And maybe that graph, goes like this. That's okay. So this is a function. Okay. However, this next one is not a function. Oh, I wrote function up there. It kind of went off the board. This is not a function. If you notice, for every input, sometimes there's 1, sometimes there's 3 or 2 outputs for the same input. Remember, input is graphed on the x-axis. So this is not a function, right? This one's not a function, whereas this one is a function. Even if these two outputs look the same, these look like they're on the same line there. Okay, that's okay. But this one with multiple outputs for the same input makes it not a function. So far, this is pretty confusing because all of the equations that we've been graphing so far are straight lines. And in 8th grade, that's all you're going to be expected to graph is a straight line. And all straight lines, except for the ones that go straight up and down where the slope is undefined, all the other ones that you are expected to know how to graph are going to be functions. It's not until later in your math career when you get into high school that you'll get really interesting where, and then you may have seen them when you've played on a graphing calculator, where you get cool equations that do something like this. This, even though it looks really cool, and I can give you the equation for this line or for this curve, this is not a function, because if you look here for this input, I've got two possible outputs. So this is not a function. But every line that you're going to come in contact with is a function, because for every input, there's only going to be one y value or one output. If you turn to page 155 in your textbook and you take a look at the Your Turn number 4 and 5, you'll notice that number 4, both the input of 8 and the input of 9 will give you 1. And that is okay. That is still a function. However, in number 5, the input of 3 gives you the output of 0, 2, 4, and 6. Therefore, number 5 is not a function. Take a look at those two problems to help you distinguish between what is a function and what is not considered a function. Something important to have on your paper is the definition of a function. So in your notes, make sure you say that a function assigns exactly one output to each input. Thank you.